In this video, we're going to take this Bluetooth low energy module and use it to control this LED. What is going on, everyone? Today's video is another installment in my IoT Basics series where I take different IoT modules and I show you how to get started with using them. In this project, we are going to be controlling an LED with an iOS device that is connected to our Bluetooth module. There was a lot of important information that I mentioned in the previous IoT Basics video, so I would recommend going and checking that one out first so you have more context for what we're about to do. And as always, the project files for this project will be uploaded to the RGB Engineering Patreon page, so feel free to check that out if you want some more content. There will be a link in the description. Okay, so a quick overview of the hardware and materials we will be using for this project. On the left, we have our iOS device that will be running the Bluefruit Connect app. This is the app that allows us to connect to and communicate with the Bluetooth module. Next to that is the Bluetooth Low Energy Spy Friend from Adafruit. This module uses the nRF51 chip from Nordic Semiconductor to run the BLE protocol and interfaces with the Arduino via SPI communication. Then finally, we have the Arduino Uno. The Arduino Uno operates using 5-volt logic, so it is important to double check that the BLE module is compatible and will not get damaged. It does not matter which specific LED you choose for this project, but make sure that you use a properly sized current limiting resistor to avoid damaging it. It may be a good idea to use a breadboard for easy circuit building, and color-coded wires might also help distinguish between the different signal lines. All of the materials for this project will be linked in the description below. Wiring up the BLE module is going to be the same as in the previous video, so I won't touch on it too much here. In addition to the various SPI lines, the BLE module also needs a GPIO connected to its interrupt pin labeled IRQ. We are going to connect the anode pin of our LED to GPIO 5 on the Arduino. The cathode of the LED can be connected to the ground bus on the breadboard, which is connected to the ground of the Arduino. A quick test to show that our LED is wired correctly and the BLE module is receiving power, and we are on our way. In the last video, we showed how to download the Adafruit Bluefruit nRF51 library and import the BlueArt data mode example. For this project, we will be using the Bluefruit nRF51 library from Adafruit and a version of our Hello World sketch as a starting point. The point of the Hello World sketch was to simplify the data mode example and get a good understanding of how the Bluetooth communication protocol works. For this project, we are going to take it a step further and start to process the data that comes in from the module. Our goal is to modify this code so that when the message on is sent, the Arduino will turn the LED on, and when the message off is sent, the Arduino will turn the LED off. So let's quickly run the Hello World sketch and review how the data comes in from the module. If you remember from the last video, the end of every message is denoted by a \n character or a 10 on the ASCII table, so we have filtered that out with an if statement. Now we see just the message being printed to the serial monitor. Notice how each individual character gets separately printed to the serial monitor. This is because our temporary storage variable C can only store one value at a time. In order to process the on-off commands, we will need to concatenate the data into a single array. We can do that by using an if statement like this. Next, we will want to convert our array to a string so we can compare it to the on-off commands. The first step in this conversion process is going to be to figure out when the full message has been received. We can actually use the new line character in this case to our advantage and allow us to detect when the end of the message has been reached. After we have detected the end of the message, we need to convert our array to a string, reset the array counter for the above if statement, and clear our BLE data array. Now we are ready to compare the string to our on-off commands. Using a simple if statement, we can compare the BLE string to the on string and the off string, and then write the GPIO pin high or low accordingly. And that is pretty much all we need to do to control the LED. So now we can upload the sketch and run the program. As you can see, whenever we send the command on to our BLE module, the LED lights up. And whenever we send the command off, the LED turns off. Congratulations, you've blinked the LED. Thank you so much if you made it to the end of the video. Hopefully I will see you in the next one.